So, dear learners, today we are going to start the new session that is based upon the deep learning. Deep learning is a subset of machine learning. Here we are going to discuss about neural network. Neural network is nothing but it is just like a human brain. In the human brain, we have a smallest unit that is called neuron. Neurons are used to transfer the information in the brain. Same concept we have implemented in the deep learning. So let's get started. So deep learning is a mimic of neural network in the brain. And if you want to see the neural network, how its neurons, how they looks like. So neuron. Okay, so neuron is nothing but it looks like dendrites. Some parts are there. I will show you in my machine learning book. We have neurons. So this is neural net neuron. So neuron looks like this. So here in this neuron, we have a dendrites. This side information is getting transferred and this side information is getting collected. And in the center, we have a nucleus. We have a cell body. This is cell body. And these connectors are known as axons. And myelin sheath, the small dot, you can see myelin sheath and node Ranvier, and finally axon terminal. So axon terminal is connecting to another dendrite. So like this, it creates a huge amount of big neural network, and this is how human brain works. Parallelly, it is a subset of machine learning and based on the artificial neural network with the representation learning. So only we are using here neural networks. It is called the deep learning because it is uses deep neural networks. Deep neural network means we are having more than one hidden layers in the neural network. So we will be adding many hidden networks in neural model training, and this learning can be supervised, semi-supervised, unsupervised, any type of it may be possible. Deep learning algorithms are constructed with the connected layers. So obviously on one side we have input layer, and in middle we have a hidden layers, and as a output we have a output layer. So the word deep means network joins neurons in more than two layers. So let's take a graph why we should learn deep learning and why should not machine learning. If you are going in machine learning, as you immediately the learning graph increases, you can see in the red one. But on the other hand, if you are going with deep learning it is continuously, it is improving the model. So deep learning, that is why it is important to learn. Deep learning having some frameworks. Usually you can use many or anyone you can use. TensorFlow, Keras, MaxNet, PyTorch, Cafe, Microsoft Cognitive Tools, DL4J, Onyx, and the newer one framework is JAX, JAX. This framework from Google. Google has introduced especially for deep learning. This JAX is developed on top of the NumPy library. I have a complete course on NumPy as well. So you can see here we have a complete course on NumPy as well. JAX. This is my all repository, JAX framework. So this is JAX framework from Google. So we will discuss next video about JAX. So let's come back to the deep learning framework. So how it looks like. So as we have discussed already, so neural network having minimum three type of layers, three three type of layer. First one is input node. So input node is nothing but they are just getting information. Input 1, input 2, input 3, input 4, like this, so on. And these output, whatever they generated output, this output is being given to another hidden layer nodes, and they again process and they passes output to next, and finally we got the output in the output layer, and that is final output. So as you can see, arrows are only going forward, so that is why this term is known as forward propagation. If these arrows is being trained by itself, but again back to same output can become input to the same, then we call it back propagation. These terms you must have to keep in mind. Deep learning versus machine learning. Deep learning is a subset of machine learning. In machine learning, features are provided manually, but in the deep learning, everything done by automatically. Whereas deep learning learns features directly from the data. So what are the steps are involved? So first of all, we need to understand the problem. We need to identify the data, maybe tabular data, classic classification based data, or it is deep learning algorithms, training models, and finally testing model and deployment in the production environment. A neural network with 4 layers will learn more complex features than 2 layers. So as much of hidden layers will be involved, your data or your accuracy of your model will be improved. So that is why try to put more hidden layers. But problem with this hidden layers, it require huge computation. So that is why your computer should have a good amount of CPU. CPU is needed in this. And if you can add GPU, if you can add TPU, then process can be very fast. So basically two phases are involved in this, first phase and second phase. In the first phase consists of applying the nonlinear transformation of the input and create a statistical model as output. In the second phase, we are aiming to improve the model with the mathematical method known as derivatives. So that is why we call it derivations. You should know derivatives, integral, calculus, statistics. You must have to be have a little knowledge about them. Then only we can proceed with machine learning, deep learning. Basically, there are two type of neural network we have. First one is shallow neural network, and that one is deep neural network. As I said, shallow neural network means we have a one hidden layer, one input layer, one output layer. That means it's shallow neural network. This type of neural networks are not good for training models. But as a as a simplification or simply understand purpose is okay. But deep neural network is important. More than one layers, hidden layers, you can put it. So especially the Google has launched LENet, LENet model, and that is used for image recognition. They have used 22 hidden layers. So 22 plus 2. So that means total 24 layers. As just now we said, feed forward, we are getting input to the neuron, and we are processing and giving output to next neuron. So this process is known as feed forward neural network. Just opposite of that, output of the same neuron becomes the input for the same neuron. We call it back propagation. Back propagation is a way to manage or to generate the correct output, almost correct output, or to improve the accuracy of our model. So this term we will use in the upcoming neural network, that is called RNN. Feed forward things we are using in the CNN. We'll discuss all these neural networks in upcoming. So RNN is a multi-layer neural networks that can store information in the context node, allowing it to learn data sequence and output as a number or another sequence. In simple words, we can say neural network those uses connection between includes a loop. So loop means it is giving output to itself. So to correct the to make corrections or to optimize the output. So our RNN is very useful in terms of image processing. Let's see the example of neural network. So on the left hand side, we have an input layer giving output to the hidden layers. Hidden layers itself, they are generating something, and finally we are getting output. So this is the explanation about whatever I explained, same thing. Where we can use RNN, where you are going to use anomaly detections, fraud detections, image caption, and power chatbots. So it is very popular RNN, and myself published more than 40 papers, research papers on CNN and RNN. So you can check my research paper, you search my name on the Google and you can find all about me. So let's take an example. You just search my name on the Google. And next one is convolutional neural network. CNN is a multi-layer neural network within this unique architecture designed to exact increasingly complex feature of the data at each layer to determine the output. CNN well suited for perceptual task, the feed forward task. CNN is mostly used when there is unstructured data set, unstructured like images, video type of data set we can use. And in the technically images and videos, video is nothing but it's a group of images because more than 25 images getting 25 or more than 25 images getting passed through your eyes, so it looks like a video. It feel like a video. It's not video, it's a group of images that is passing through 25 or more than 25 in front of your eyes. So that's how it feel like images of video is moving. So that is again an image. The CNN receives an image of, let's say, a cat. This cat image in the computer term we call collection of pixels. Every image is a collection of pixels. Generally one layer of the grayscale picture and three layers of for a color picture. So that is why in many cases we are using grayscale images for training purpose only. This is how we can uh, improve the performance, or we can decrease the learning time of our model. Next one is reinforcement learning. Reinforcement learning is subfield of machine learning where system is getting trained by itself by their observation. And here we have a concept of reward and punishments. If model is, or you can say agent, model or agent is the same thing. If agent is performing well, so we will give some awards. Awards is nothing in terms of numbers. If model is doing something wrong, then we are giving penalty. So that's how it learns. So in at house, children's they learn the same way. If children's are learning and we appreciate them, and sometimes we are giving punishments as well. So let's take an example of reinforcement learning. We have input data and apple or not apple. So computer will agent will learn here. Sometime it may make a mistake. So in that case, no, it's not an apple. And based on the learning, it will recognize, yes, this is an apple. Finally, output it will get. Reinforcement learning needs huge amount of computation. I will show you all these by hands-on. In my courses, you will find complete hands-on. 90, 85 to 90% you will see hands-on, and 10 to 15% you will find theory. So basically, these are few reinforcement learning algorithms. These all I have published in the book as well. I have five books, and fifth book, sixth book is under publication, and maybe in this month it will be out. It will be available in the Play Store. You can search my name and you can find books. So very popular algorithms are Q learning, deep Q learning, and state action reward, state action, deep deterministic policy gradient. So these algorithms we'll discuss. Basically, I will be using two frameworks here in this training, PyTorch and TensorFlow. Sometimes PyTorch, sometimes TensorFlow. It is not about like I cannot do the same thing in the PyTorch or same thing I cannot do the in TensorFlow. But the reason is I want to make you learn in the both, expert in the both. All right. Thank you. Thank you so much for joining.